Welcome to the DIY Honda Garage channel. The DTC P0523 indicates that there is a high voltage reading from the engine oil pressure sensor circuit in the Honda Accord models from 2017 to 2023. This error may potentially compromise engine performance and oil pressure monitoring. The engine oil pressure sensor is responsible for measuring the amount of oil pressure in the engine and sending that information to the Powertrain Control Module, or PCM. The PCM uses this data to regulate engine operation and ensure optimal performance. The sensor is typically located near the oil filter and is connected to the engine via a 3P connector. When high voltage is detected, it usually signals either an internal sensor failure or a wiring issue in the circuit associated with the sensor. DTC P0523 signifies that the engine oil pressure sensor circuit is experiencing high voltage. The engine oil pressure sensor plays a critical role in maintaining engine health by measuring oil pressure and relaying this data to the PCM. If the sensor detects abnormal oil pressure levels, it will send a corresponding voltage signal, which the PCM interprets to make necessary adjustments. This sensor is generally situated near the oil filter, making it accessible for inspection and testing. Any disruption or irregularity in this sensor can lead to serious engine performance issues. Therefore, precise knowledge about the component's role and location is paramount for effective troubleshooting. There are various potential causes for DTC P0523. A faulty oil pressure sensor is the most obvious issue. If the sensor malfunctions internally, it could lead to erroneous readings. Wiring issues, such as frayed wires or shorts within the harness, are also common culprits for high voltage signals. Poor connections, including loose or corroded terminals, can disrupt the electrical flow and trigger this error code. Checking these areas is critical during troubleshooting, as they can often lead to intermittent failures. Identifying these issues early on can prevent more significant problems from developing down the line. When the DTC P0523 is triggered, you may observe several symptoms. The most immediate indicator is the check engine light illuminating on the dashboard. Other symptoms can include erratic or fluctuating oil pressure readings, which can be concerning as they may signal underlying engine issues. In some cases, drivers may experience reduced engine performance due to potential adjustments made by the PCM based on incorrect data from the oil pressure sensor. These symptoms highlight the importance of promptly addressing this DTC to maintain engine integrity and prevent more extensive repairs. In the first step, you'll need to verify the problem using the Honda Diagnostics System, HDS. Start by turning the vehicle to the on mode and checking the parameter of the rocker arm oil pressure sensor voltage. The threshold value should be 4.79 volts or more for proper operation. If the current conditions match this threshold, it confirms that the failure has been duplicated. If they don't match, it indicates an intermittent failure, suggesting that the system may be functioning correctly at that moment. Ensuring that you have solid connections at both the oil pressure sensor and the PCM is essential, as poor connections could lead to inaccurate readings. If you have an onboard snapshot of this DTC recorded, attempt to replicate the failure conditions, as this may provide further insight into the issue. During the second troubleshooting step, begin by turning the vehicle to the off mode and disconnecting the engine oil pressure sensor's 3P connector. Next, connect terminals A and B using a jumper wire. Terminal A corresponds to female terminal number 1 and terminal B to female terminal number 2 within the sensor's connector. Once connected, turn the vehicle back to on mode and check the voltage again using the HDS. The rocker arm oil pressure sensor voltage needs to be 4.79 volts or more. If the current conditions match this threshold, proceed to the next step indicating the system is likely okay. If not, it suggests that the engine oil pressure sensor may need to be replaced, as it is not producing the expected output under these conditions. In Step 3, first ensure the vehicle is in the off mode and remove the jumper wire you set in the previous step. Turn the vehicle back to the on mode and measure the voltage between the specified test points. Test point 1 is tied to female terminal number 1 of the engine oil pressure sensor 3P connector, and test point 2 relates to female terminal number 3. You need to check if the measured voltage is around 5.0 volts. If this voltage condition meets the expected value, continue on to Step 5 in the troubleshooting process. Conversely, if there is a significant deviation from this value, it will require further investigation to pinpoint the underlying issue that may be causing the high voltage reading in the DTC P0523. For troubleshooting Step 4, start by ensuring that the vehicle is off lock mode. Use the HDS to jump the SCS line and allow it to sit for over a minute to ensure a proper reset. After this, disconnect the PCM connector E, ADP. With both the engine oil pressure sensor 3P connector and the PCM connector disconnected, check for continuity between the specified test points. Test point 1, female terminal number 1 of the engine oil pressure sensor, and test point 2, ADP connector number 78. It is crucial to determine if there is continuity in the SG2 wire that connects these components. If continuity exists, it suggests the SG2 wire is intact, guiding you to check authorized service information or consider substituting with a known good PCM for further analysis. In the final troubleshooting step, similar to Step 4, start with the vehicle in off lock mode and jump the SCS line with the HDS, waiting for more than a minute. Next, disconnect the PCM connector E, ADP, with the engine oil pressure sensor's 3P connector and the PCM's ADP connector both disassembled. Check for continuity between the engine oil pressure sensor 3P connector female terminal number 2 and the PCM connector E number 58. This test serves to verify the ops-in line. If continuity is confirmed, this indicates the ops-in wire is functioning properly. However, should there be a lack of continuity, this suggests the need for repairs on the ops-in wire running between the PCM and the engine oil pressure sensor to rectify the issue. Following the troubleshooting and necessary repairs for DTC P0523, it's vital to perform a final repair verification. Ensure that the initial issue has indeed been resolved by turning the vehicle on and verifying that the check engine light is no longer illuminated. Additionally, utilize the HDS to check the system monitors and ensure that parameters within the oil pressure sensor circuit are within accepted thresholds. By confirming these details, you are effectively validating the success of the troubleshooting action taken. It's crucial in this step to refrain from simply erasing the DTC, but to confirm operational functionality before discontinuing service. This comprehensive verification will help deliver assurance in the repair. Preventive maintenance is essential in mitigating future occurrences of DTC P0523. Regular oil changes help keep the engine's oil cleaner and reduce buildup, which can contribute to sensor failures. Additionally, during routine maintenance, inspecting the connections to the oil pressure sensor and ensuring they are clean and secure will help avoid poor electrical connections that can lead to intermittent or consistent faults. Considering the environment in which the vehicle is operated can influence sensor longevity and performance. Therefore, staying proactive about vehicle inspections is vital. Making preventive maintenance a habit will significantly enhance the lifespan of the engine and its components. In conclusion, Understanding DTC P0523 and its implications is crucial for maintaining the performance of a Honda Accord from 2017 to 2023. Following a structured troubleshooting approach enables accurate diagnosis and effective repair of the engine oil pressure sensor circuit issue. Clear steps from problem verification to systematic testing of electrical connections guide the technician in resolving the fault effectively. Furthermore, committing to preventive maintenance practices will help in extending the life of the oil pressure sensor and enhance overall vehicle reliability. By being proactive and educated about such DTCs, vehicle owners and technicians can ensure optimal performance and reduced repair costs over time. Please like and subscribe to the channel. See you next time.